These are the speed of light in different media. In vacuum, the speed of light is maximum in vacuum, that is 3 multiplied by 10 to the power 8 meter per second. In air, it is approximately 3 multiplied by 10 to the power 8 meter per second. So vacuum and air considering same speed of light. Water, it is 2.25 multiplied by 10 to the power 8 meter per second. Glass, 2.00 10 to the power 8 meter per second. Diamond, it is 1.20 multiplied by 10 to the power 8 meter per second. So depends upon the velocity of light, the medium can be rarer or denser. So here, if you consider air and water, which is optically rarer, air is optically rarer and water is optically denser, because in water the speed of light is less compared with the speed of light in air. But if you consider water and glass, which is optically denser and which is optically rarer, glass is optically denser, water is optically rarer, because the speed of light in glass is less than that of in water. So glass is optically denser, water is optically rarer. Then if you consider glass and diamond, which is optically denser and which is optically rarer, diamond is optically denser and glass is optically rarer, because the speed of light in diamond is less compared with the speed of light in glass. So you can't say always water is optically denser. Depends upon the second media, depends upon the other medium only you can say one medium is optically denser and optically rarer. Optically denser simply means the speed of light is speed of light is minimum there, and optically rarer means the speed of light is maximum. So these are the speed of light in different media. So depends upon the speed of light in the medium. The medium can be optically rarer or optically denser. When refraction takes place, you must note the frequency of light remains same. That means when light travels from one medium to another, the frequency of the light remains same. You know this equation, V equal to F lambda. This is the fundamental relation. V is the speed of light here, F is the frequency of light, and lambda is the wavelength of light. V is the velocity, F is the frequency, and lambda is the wavelength. So when refraction takes place, frequency of the light remains same. So by considering this equation, frequency is a constant. So if you remove that constant by proportional sign, V becomes V directly proportional to lambda. That means what? When the velocity of light increases, wavelength also increases. When the velocity of light decreases, wavelength also decreases. So you can form an equation V1 divided by V2 equal to lambda 1 divided by lambda 2. So V1 represents the speed of light in the first medium, V2 represents the speed of light in the second medium. Lambda 1 represents the wavelength of light in the first medium, lambda 2 represents the wavelength of light in the second medium. So these are the relation connecting velocity and wavelength of light. So when refraction takes place, frequency of the light remains constant and wavelength of light can change. Velocity of light can change. So when refraction takes place, velocity can change, wavelength can change, amplitude of light can change, intensity of light also can change. So During diffraction, velocity of light can change, wavelength of light can change, amplitude of light can change, wavelength of light can change. So during refraction, these are the changes taking place. But frequency of light remains constant. Frequency remains constant. Frequency of light remains constant. So frequency of light remains only constant during refraction. Velocity of light, wavelength of light, amplitude of light and intensity of light changes during refraction of light. So this is the relation connecting wavelength and velocity of light. Wavelength and velocity of light are proportional. Wavelength of light and velocity of light are proportional. These four quantities will change during refraction. In the case of reflection, you studied laws of reflection. In the same way, in the case of refraction, you are studying laws of refraction. What do you mean by laws of refraction? Which are the laws of refraction? First law is the incident ray, the normal and the refracted ray at the point of incidence all lie in the same plane. The incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. That means what? The incident ray or the refracted ray will not enter into another plane or will not enter into another surface. So the incident ray, the normal and the refracted ray at the point of incidence all lie in the same plane. That means we are drawing here incident ray, refracted ray. This is in a single plane. Okay. And this refracted ray will not enter into another plane or another surface. So the incident ray, the refracted ray and the normal all lie in the same plane. That is the first law of refraction. The second law of refraction, it is known as Snell's law. It is known as Snell's law. It is very simple. The sine of the angle of incidence and the sine of angle of refraction. So the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. It is known as refractive index of the medium. That is N2 refractive index of the medium. So here the incident ray is shown. This is the refracted ray. This is the angle of incidence. This is the angle of refraction. Medium 1 and medium 2. So when light travels from one medium to another, there will be an angle of incidence and there will be an angle of refraction. Here the angle of incidence is represented by I and the angle of refraction is represented by the letter R. So the ratio of the sine of angle of incidence to the sine of angle of refraction, that is a constant. That constant is known as refractive index of the medium. Refractive index of the medium. So the ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant. That constant is known as refractive index of the medium. As you learned, refractive index means it is the ratio of sine of the angle of incidence to the sine of angle of refraction. When light travels from one medium to another, there will be an angle of incidence and there will be an angle of refraction. So the ratio between the sine of angle of incidence to the sine of angle of refraction is known as refractive index. Refractive index of a medium depends on nature of pair of media 1 and 2. That means you know that in refraction, refractive index, it's a comparison also. You know that denser and rarer, it's a comparison. Refractive index also with respect to a medium. So refractive index depends upon what? Nature of pair of media 1 and 2. Refractive index depends upon the pair of media 1 and 2. From one medium to another, refractive index will change. If you consider air and water as the pair of media, or glass and diamond as a pair of media, or water and diamond as a pair of media, the refractive index will be different. So refractive index depends upon the pair of media 1 and 2. Refractive index depends upon the wavelength of the incident ray. Refractive index depends upon the wavelength of the incident ray. That is, higher the wavelength, smaller will be the refractive index, and vice versa. Higher the wavelength, smaller will be the refractive index. So higher wavelength, smaller refractive index. Smaller the refractive index, smaller the wavelength, higher will be the refractive index. So they are inversely proportional. So higher the wavelength, smaller will be the refractive index, or smaller the wavelength, higher will be the refractive index. So N21. N21 means the refractive index of the medium 2 with respect medium 1. N12, refractive index of medium 1 with respect to 2. So refractive index we are taking by considering two media. By considering two media, so their symbols are N21 and N12. N21 means what? Refractive index of medium 1 with respect medium 1. N12 means refractive index of medium 1 with respect to medium 2. So it will change. So I already explained wavelength of the incident ray depends upon the refractive index. They are inversely proportional. So violet light, you know it, violet light is having minimum wavelength. Violet light is having minimum wavelength. So it is having higher refractive index. Red light is having maximum wavelength. So it has minimum refractive index, because wavelength and refractive index, they are inversely proportional. So refractive index, wavelength of red light is more than the wavelength of violet light. So because of that reason, refractive index of red will be less than refractive index of violet. So violet is having more refractive index. Red is having minimum refractive index, because red is having maximum wavelength. So refractive index depends upon the two media. It will change from one pair to another pair. So Snell's law you can define in a full form how for a given pair of media, and for a given color of light, or for a given pair of media and for a given wavelength of light, the ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant. So Snell's law you can define like that, because refractive index depends upon pair of media and wavelength. So including these two, we can define Snell's law. For a given pair of media and for a given wavelength, the ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant. So that law is known as Snell's law. Another thing is the refractive index has no unit, because you know that refractive index is the ratio of the angle. Refractive index is the ratio of the angle. So you know that the same physical quantity comes as a ratio. So you know that refractive index sin I, refractive index equal to sin I by sin R. These two are angles. Sin I and sin R, you will get a number. Sin I is a number, sin R also a number. So the ratio becomes unitless. The refractive index has no unit, because it is a ratio of two numbers. Sin I is a number, sin I R also a number. So refractive index has no unit. That thing you have to keep in mind. So these are the factors that depends upon the refractive index of a medium, which are the first depends upon the nature of pair of media, wavelength of light. So how can you state Snell's law? For a given pair of media and for a given wavelength, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. So that constant is known as refractive index of the media. So that refractive index can be N21 or N12.